Look around you right now, feel the solid texture of your desk, and listen to the faint hum of the room. Everything about your physical world feels indisputably real, concrete, and grounded in absolute material reality. What if the most brilliant physicists on Earth are right when they suggest that everything you experience is an illusion? What if our entire universe, including your body, is just a flat 2D hologram projected across space? In the next 20 minutes, modern physics is going to break your perception of reality forever. Look at your hands. They feel solid, right? But quantum mechanics proves that at a microscopic level, physical matter is mostly empty space. And by the end of this video, you will understand the exact mathematical proof that explains why physical distance might be a complete lie. But first, we have to look at a massive disaster in modern science. For over a century, the greatest minds on Earth have been trapped in a war between two scientific theories. Einstein's relativity explains the massive cosmos, while quantum mechanics explains tiny subatomic particles. The problem? They completely contradict each other. When you try to combine their equations, the math literally explodes into useless infinities. To fix this broken math, theoretical physicists had to look at the most dangerous objects in existence, black holes. Now, what I'm about to tell you sounds like pure science fiction, but it was proven by Stephen Hawking himself. Intuition tells you that the capacity of any container depends on its 3D volume. If you pack a room with books, the space inside determines how many you can fit. Logically, a black hole should store matter inside its volume, right? Wrong. When physicists calculated the information limit of a black hole, they got an impossible result. The capacity doesn't depend on its volume at all. It scales strictly with the surface area of its flat, 2D outer edge. Every single thing that falls inside a black hole is compressed and written directly onto its surface, like data on a hard drive. Think about that. A three-dimensional object completely stored on a flat, two-dimensional wall. Which brings us to the terrifying question. If a black hole operates like a hologram, could our entire universe be doing the exact same thing? Stick with me because the math gets even crazier. In the late 1990s, physicist Juan Maldacena dropped a bomb on the scientific community. He mathematically proved that a complex 5D universe with gravity is identical to a flat 4D universe with zero gravity. Every event happening in the complex world is just a mirror reflection of data on the flat boundary. Gravity itself might not even be real. Imagine watching a 3D movie at the theater. You put on your glasses, and suddenly an asteroid is flying straight at your face. You flinch. To your brain, that object has depth and distance. But if you walk up to the screen and touch it, it's completely flat. The third dimension was an illusion created by light projection. In just a moment, I'm going to show you how this holographic illusion effortlessly solves the creepiest mystery in quantum physics, a phenomenon Einstein himself was terrified of. Look at quantum entanglement. When two subatomic particles become entangled, you can separate them by billions of light years. If you flip the spin of particle A on Earth, particle B on the edge of the galaxy instantly flips at the exact same millisecond. Einstein called this spooky action at a distance because nothing travels faster than light. But in a holographic universe, there is no distance. Those two particles aren't miles apart. On the flat 2D surface where the raw data lives, they are sitting at the exact same coordinate. The space between them is just a rendered graphic on your screen. To understand how deep this illusion goes, we need to ask an even fundamental question. What is physical matter actually made of at the absolute smallest scale? If you break down a chair, you get molecules. Break down molecules and you get atoms. Break down atoms and you get subatomic particles like quarks and electrons. For centuries, classical physics taught us that these particles were tiny physical spheres, like billiard balls bouncing around in empty space. But quantum mechanics smashed that model to pieces. When we look closely at these particles, we find that they don't actually have a fixed physical location until we measure them. Instead, they exist as mathematical wave functions, clouds of pure probability floating through empty space. A subatomic particle is essentially a list of mathematical odds, waiting for an observation to force it into choosing a physical state. This leads us directly to the legendary double-slit experiment, one of the most disturbing tests in the history of science. When light or electrons are fired through two narrow slits onto a detector screen, they create an interference pattern, behaving like waves in a pond. However, if scientists set up a camera to watch which specific slit each individual electron passes through, the particles completely change their behavior. The mere act of observation causes the wave function to collapse, forcing the electron to behave like a solid, physical marble. The universe literally changes its fundamental behavior based on whether a conscious observer or a measuring device is looking at it. Why would physical reality wait for an observer before deciding what to do? In modern video game engines, developers use a brilliant programming trick called occlusion culling or dynamic rendering. To save processing power, the computer only renders the environment that falls directly inside the player's field of view. The mountain range behind your character doesn't exist as fully rendered 3D graphics until you turn your camera to look at it. Rendering the entire world at once would cause the central processor to instantly overheat and crash the program. The double-slit experiment demonstrates that our universe operates on the exact same conservation of computational resources. Matter remains a vague mathematical probability until an observer forces the system to render a physical result. This discovery pushed physicists to look closer at the fundamental structure of space and time itself. Is space continuous, like a smooth sheet of glass, or is it divided into tiny, indivisible individual blocks? Max Planck, the father of quantum mechanics, calculated the theoretical absolute limit of physical measurement, now known as the Planck length. If you try to measure anything smaller than the Planck length, the laws of physics completely break down and gravity collapses into microscopic black holes. This means space is not a smooth, infinite continuum. It is pixelated, broken up into tiny discrete units, measuring roughly 10 to the minus 35 meters across. Just as a high-definition television screen is built from millions of individual static pixels, the universe appears to be constructed from a cosmic grid of Planck-sized pixels. You cannot move a distance shorter than one Planck length. Matter simply hops from one pixel grid coordinate to the next. Time itself follows the exact same pixelated rules, measured in discrete chunks called Planck time, the duration it takes for light to travel one Planck length. Our reality does not flow in a continuous stream like a river. It ticks forward in discrete frozen frames at a rate of 10 to the power of 43 frames per second. Reality has a resolution, and reality has a frame rate. Now, consider the ultimate cosmic speed limit, the speed of light. Light travels at roughly 300,000 kilometers per second in a vacuum, and according to Einstein, nothing in the universe can ever move faster. Why would the universe have a hard speed limit in the first place? Why couldn't an advanced rocket ship with infinite fuel accelerate past light speed? In a computer program or a virtual simulation, the maximum speed at which information can travel across the screen is governed by the processor's clock speed. The speed of light is not a random arbitrary rule of physics. It is the maximum processing bandwidth of the hardware rendering our universe. This bandwidth limit becomes even more obvious when you study Einstein's special relativity and the bizarre phenomenon of time dilation. As an object moves faster through space, time for that object slows down relative to a stationary observer. If you fly in a spaceship at 99% the speed of light, years will pass on Earth, while only a few minutes pass for you inside the cockpit. If you reach 100% the speed of light, time stops completely. Why would moving through space affect the passage of time? Think about how a graphics card handles heavy processing loads. When a game engine handles too many complex physics calculations at once, the frame rate drops and the simulation slows down. Space and time are fundamentally bound together into a single fabric called space-time because they share the same processing budget. The more processing power the universe spends rendering your high-speed movement through space, the less power it has left to process your movement through time. This brings us to a mind-bending question. Who or what is running this cosmic processing system? In 2003, philosopher Nick Bostrom formalized the mathematical arguments for the simulation hypothesis, presenting a famous trilemma that shocked the academic world. Bostrom argued that one of three logical possibilities must be true for any intelligent species in the cosmos. First, civilizations almost always go extinct before reaching the technological capacity to run ancestor simulations. Second, advanced civilizations reach that level of technological power, but universally choose not to run simulations due to strict ethical laws or lack of interest. Or third, we are almost certainly living inside a computer simulation right now. Consider the math behind that third option. If a civilization survives and develops supercomputers, running a simulation of their ancestors requires a fraction of their energy. A single advanced civilization could easily run millions or even billions of simulated universes simultaneously, each containing billions of conscious, simulated humans. If there are millions of simulated realities containing conscious beings, but only one original base reality, simple probability takes over. The statistical odds that you happen to be living in the one real, organic baseline universe are practically zero. You are mathematically almost guaranteed to be living in a simulation. So, if we are inside a simulation or a holographic projection, can we find actual computer code written into the laws of nature? Theoretical physicist Dr. James Gates set out to answer this exact question while studying supersymmetry and string theory. He was analyzing adinkras, complex mathematical diagrams used to describe the equations of supergravity and string theory at the subatomic level. What he found inside those equations shocked the global scientific community. Deep within the fundamental equations governing subatomic particles, Gates discovered error-correcting computer algorithms. Specifically, he identified linear binary block codes, the exact same software algorithms developed by Richard Hamming to detect and correct data transmission errors in digital telecommunications. Why would the fundamental mathematical structure of raw physical space contain built-in computer code designed to prevent data corruption? If the universe were a purely natural, unprogrammed accident, finding functional error correction code in the laws of physics makes no logical sense. It suggests that our reality requires an active software protocol running in the background to prevent the fabric of spacetime from accumulating glitchy data errors over time. This forces us to rethink what happens when matter collapses down into an infinitely small point, such as the singularity inside a black hole. In classical physics, a singularity is a point of infinite density where the laws of physics completely break down and equations spit out error messages. In software design, an infinity error occurs when an equation tries to divide by zero, causing the program to freeze or crash because it lacks the instruction to handle the result. Black holes might simply be the universe's way of executing a catch block exception, a safety protocol designed to isolate crashed pixels before they corrupt the rest of the simulation. The horizon of a black hole acts as a computational firewall, trapping the broken rendering logic behind an unpassable barrier so the rest of the universe can continue running smoothly. Now, let's step back and look at the philosophical consequences of a pixelated, bandwidth-limited, error-corrected universe. What does this mean for human consciousness? For centuries, materialist science has operated under the assumption that matter is primary and consciousness is secondary. The standard narrative claims that the Big Bang created physical particles, gravity pulled them into stars and planets, chemistry formed biological cells, and eventually human brains evolved consciousness as a side effect. The holographic principle in quantum mechanics invert that entire hierarchy completely. Matter is not primary, information is primary. As the legendary physicist John Archibald Wheeler famously summarized, it from bit. Every physical thing, every particle, every field of force, every star derives its existence entirely from binary bits of information. If reality is made of information, then information requires a conscious mind to perceive, interpret, and give meaning to that data. Consciousness is not an accidental byproduct of brain chemistry. It is the fundamental medium upon which the holographic simulation is projected. Think of it like a computer game character trying to analyze the pixels on the monitor from inside the game. The character might believe the monitor is made of physical rock or metal, completely unaware that the screen is just emitting photons triggered by software logic. Your physical brain is not generating your consciousness. Your brain is a receiving terminal, an interface device rendering raw cosmic data into the subjective 3D experience of human life. So, if physical space is an illusion, what does that actually mean for your mind, your memories, and your consciousness? Here is where this theory gets deeply personal. Most people assume consciousness is an accidental byproduct of biological brains trapped in a cold physical cosmos. But if physical matter is just projected data, then consciousness might be the primary system observing the simulation. Every emotion you feel, every memory you cherish, and every decision you make is fundamental data encoded into the universe itself. You are not a tiny human floating on a random rock in an endless void. You are the user experiencing the projection. Is this just crazy philosophy? Absolutely not. Right now, scientists are using ultra-sensitive laser detectors to search for the physical pixels of our reality. They are looking for tiny subatomic glitches in spacetime known as holographic noise. If these experiments confirm the noise, it will trigger the single greatest scientific shift in human history. It will prove that everything we fight over, build, and dream about is an intricate, beautiful projection of pure information. Whether physical space is real or an optical trick of quantum math, your experience remains real. The warmth of the sun, the beauty of music, and human connection do not lose their value just because they are made of code. Perhaps the ultimate meaning of life isn't figuring out if the universe is real, but making your time inside the projection truly matter. Does the holographic principle make you feel insignificant or strangely connected to everything? Let me know in the comments. Hit that subscribe button to keep breaking reality with us, and I'll see you in the next dimension.